An electric current can either be alternating or direct. Batteries that you find in torches and iPods produce a direct current, since the electricity is flowing in one direction only, as you'd expect. However, when you switch on a light or a TV at home, you're using an alternating current, since the mains use an alternating supply. What this means is that the current is repeatedly reversing direction, flowing one way and then the other in very quick cycles. Its frequency is the number of cycles it completes in 1 second. In the UK, the frequency is 50 Hz. An alternating current is more convenient when considering things like generators and transformers, and it's just as efficient with appliances as a direct current would be. Because an alternating current's potential difference is constantly changing between positive and negative, we have to give it an average voltage. In the UK, the mains potential difference ranges from positive and negative 325 volts, but we say the voltage is 230 since this is an average. We can use an oscilloscope to visualize how an alternating current changes with time.
When you plug in an appliance such as a kettle to the plug socket, you earth the metal case. This stops the live wire from damaging anything. The outer casing of both plug and socket is made of plastic. Plastic is a good insulator and is quite durable. In a plug there are several key components: earth wire, live wire, neutral wire, fuse and cable grip. The pins to the socket are made from brass, as brass is a good conductor and doesn't oxidize. The wires are made from copper, as copper is a good conductor and is flexible. The fuse is located between the live wire and live pin. This is so that it can cut off the electricity if too much current passes through.
Fuses are used in appliances as a safety feature. A fuse contains a thin wire that heats up and melts if too much current passes through it. If this happens, we say the fuse has blown. If a fuse blows, it cuts the current off. The rating of the fuse is the maximum current that can pass through it without melting the wire. If the fuse rating is too small for the appliance, it will blow as soon as it is used. If the rating is too high, it might let through too much current and damage the appliance, potentially causing a fire.
Power is essentially the energy that an appliance transforms every second. Power is energy transferred divided by time. And there's many other things you can learn as well, like the current. The current is essentially the measure of the number of electrons passing through it each second. The potential difference, of course, is the measure of how much energy each electron passing through it transfers. And the power supplied is therefore the energy transferred to it each second. So you can learn another really good formula, like power supplied equals current times potential difference. But you have to remember that power supplied is in watts, and that is equal to current in amps times by potential difference in volts. And that is basically it, really. You can also work out the current from power supplied divided by potential difference, and therefore you can choose a fuse.
When you switch an electrical appliance on, the potential difference of the voltage supply unit forces electrons through the appliance, carrying a flow of charge. Charge is measured in coulombs. 1 coulomb is the amount of charge flowing through a component in 1 second when the current is 1 amp. A resistor contains vibrating atoms. A battery connected to a resistor forces electrons to pass through. They collide with the vibrating atoms, passing kinetic energy to them. When charge flows through a resistor, electrical energy is transformed into heat energy. Charge flow in coulombs equals the current in amperes times time in seconds. Energy transformed in joules equals potential difference in volts times charge flow in coulombs.